Hello guys, welcome back to Maison African Motives. Still working on A-level maths, working on revisions. Now we are on partial fractions, working with the past exam papers. In this case, I have some question papers that I just took so that we can have a revision on partial fractions and also seeing how do they ask these typical questions. So we are given question number 9, it is given that f of x is given as x cubed plus 2x squared plus x plus 2 over x squared plus x. Express f of x in the form px. So we are given a format in this case of how we are going to express our f of x. All right, so let's see how this question was supposed to be answered in this case. All right, so let's just see here. We are given our f of x. In this case, that was our question 9, where f of x is given as x cubed plus 2x squared plus x plus 2. Everything over, we are given this as x squared plus x. And we are told that this f of x can be written as f of x is equal to the function of px, that's px plus a over x plus b over x plus 1. All right, so in this case, they try to give us a certain hint on how to express our f of x into partial fractions. So the first thing that we are supposed to check here is the condition of the fraction. Is it a proper fraction or is it an improper fraction? Checking here, the LCM, the denominator that we have here, we have got the exponent, which is 2. And in the numerator, the highest exponent, which is 3. So the highest exponent in the numerator is 3. In the denominator is 2. That means this is an improper fraction because we're having the highest exponent in the numerator. That makes it an improper fraction. So if it is an improper fraction, how are you going to simplify it? On a condition that the degree of the numerator is equal to the degree of the denominator, or the degree of the numerator is greater than the degree of the denominator, you divide. So as long they are equal or being greater than, you are going to divide in that case. So we are going to perform our long division where x squared plus 1 is going to be divided into this expression of x cubed plus 2x squared plus x plus 2. So we are going to perform long division so that we can obtain a proper fraction. Just like normal numbers, if we are given 6 over 5, it's an improper fraction. The moment you divide 5 into 6, this is going to give us 1, having a remainder of 1 over 5. That means we are now having a whole number and a proper fraction because now 1 is less than the denominator, which is 5. So that is the same condition even for algebraic fractions. So remember, from our long division, we talked about this before. So if you're not, if you haven't watched that video, please make sure that you watch so that you can have basic understanding on your long division. All right, so dividing the first term to the first term, that's x cubed, divide by x squared, which is x. Then remember, whatever that you obtain, you are going to multiply back everything here. This is x is going to multiply everything back here. So that is going to be x times x squared, which is x to the exponent of 3. X times x, this is going to give us x squared. So after dividing, after multiplying, we are going to subtract. We have multiplied, we subtract, in this case, x cubed minus x cubed, that will cancel. 2x squared minus x squared is same as 1x squared. So 2 minus 1, that is going to be x squared. So we have subtracted. In this case, we obtained x squared. The rest of the terms, we are going to drop these terms down. So this is going to be plus x plus 2. All right. We can divide again the terms. So that means we are going to divide again. The condition is always of the first term versus the first term. So now this is x squared divide by x squared, which is going to give us a 1. So 1 is going to multiply everything. 1 times x squared plus x. This is going to be x squared plus x. Then we subtract. So if we can subtract, that's x squared minus x squared, which gives us a 0. X minus x, that's a 0 again. So we are going to remain with just a positive 2, which is our remainder, because we can't divide here. 2 divide by x squared. We can't divide here. So that means this is your remainder. Just like what we saw on this fraction, we saw that we are going to have a proper term, which is a single term, which is in this case a whole number of 1 in this case. So this is the one that we have here, which is x plus 1. So that means we can write this as equivalent to, after this whole division that we have, our f of x can be written as this x plus 1, which is x plus 1, plus the remainder over the part that was dividing. So our remainder is 2. So it is going to be 2 over, we were dividing by what? By x squared plus x. So this is how the whole part of f of x can be written as, from what we were given here, our f of x as an improper fraction. Now we are having f of x as a proper fraction, because 2 is this part, we are having a lesser degree in the numerator than the one that is in the denominator. But we haven't expressed yet into partial fraction. This is the first part, your long division. Then from there, we are going to express into partial fraction. This part that we have now in what? In a simplest form, or as a proper fraction. So remember your partial fractions, we say the denominator, if it factorizes, please make sure that you factorize that. So can we factorize x squared minus x squared plus x? Can we factorize? Yes, x is common, so this is going to be x plus 1. So meaning to say, this whole part that we have, what are we converting? We are working with this part alone, this part. We can't convert x plus 1 into a partial fraction. So we just leave this as it is, all right? So we're just going to leave this as it is. We are focusing on 2 over x squared plus x. So this is the whole part that we are focusing with. That's x squared plus x, which we said we can factorize this into 2 over the 2 part here, which is x into x plus 1. So what type of factors are we having? These are linear factors, which is equivalent to a over the first term, which is x plus b over the second term, which is x plus 1. So we are going to determine the value of a and b from this case by focusing with these 2 in this case, the one that is now in factorized manner. So that means equating the numerators, 2 is equivalent to a. If we divide this LCM to x and x will cancel, you remain with x plus 1. So this is going to be x plus 1 plus b. If we divide x plus 1 and x plus 1, we remain with x. So it is going to be bx. All right, so this is where we are. Remember that we have to find the value of a and b, so we can equate x plus 1 to 0. That means if x plus 1 is equated to 0, x is going to be equal to minus 1. So we can say when x is equal to minus 1, that means this whole part is going to be eliminated, because minus 1 plus a 1, that's a 0. So we are going to have 2 is equal to, eliminated this part, we are remaining with here. We said x is minus 1. So this is going to be minus 1 times b, which is minus b. So finding the value of minus b, the value of b, we can divide by -1 so that we can have the exact value of b. So the exact value of b in this case is going to be a negative. So we have got -2. 2 divided by -1. That's a -2 in this case. So now having the value of b, we can calculate the value of a by letting this part of x to be equal to, but we are just having x there. So if x is equal to, which means we can eliminate this whole part. All right, so that's it. When x is equal to 0. So 2 is going to be equal to, this is now 0 plus 1. So 0 plus 1, that's 1 times A, which is A. Then here, this is a 0. 0 times B, that's a 0. So which means A is equal to 2. So we have the value of A and also the value of B. So we are going to substitute these values into this function that we are given before. Remember, we said our f of x can be written as x plus 1. So now we are going to have our f of x starting with the x plus 1. Then we move on to the other part. So therefore, our f of x is equal to x plus 1. That's the first part that we got in this case. Then this part here, 2 over x squared plus x, is the one that we converted or that we resolved into partial fractions of a over x plus b over x plus 1. So we are going to substitute now here a, which is 2. So it is going to be 2 over x. So we are going to have, it is a plus here. Take note, this is a plus. So plus is not going to affect anything. So it's 2 over x in this case. So we're going to have plus 2 over x. All right, let's just try to write it this way, plus 2 over x. We move on to b, which is minus 2. So it is going to be minus b, which is minus 2 over. So that is our b, which is minus 2. So it's supposed to be b over x plus 1. So that's minus 2 over x plus 1. So this is what we're going to have at the end. All right, so this is our f of x. Remember that our f of x is supposed to be written in the format of f of x is equivalent to px plus, it was given as a over x plus b over x plus 1. So this is the format that you're given. And this is the same format that you can see. Our px is this function, a over x, which is this part, the b over x plus 1, which is this part. So that is what the question was simply asking you to do in this case. All right, so we've got our f of x. Let's check the other part of the question from this f of x that we are given in this case. So we are now given on b part. All right, let's just a little bit on b part here. Hence, find the exact value of the integral of f of x with the limits 1 up to 2 with respect to x. That's 4 marks. Okay, so what is this question saying? Yes, it's a continuation. Remember that you now have your f of x here. You converted your f of x from this part into linear or into partial fractions, which is of linear nature, the one that we got. Now the question is asking us on the second part, which is the b part here, to say that, okay, let me just write it the way it was given. The integral of f of x with respect to x from the limits 1 up to 2. So from your integration, you are supposed to integrate your f of x, which is this function that we got here. So it means that this is going to be equivalent to the integral of we've got our limits 1 up to 2. This whole function as it is, which is x plus 1 plus 2 over x minus 2 over x plus 1 with respect to x. So that is what you're going to do in this case. So now it's part of your integration. We are no longer dealing with partial fractions here. This is integration. So remember that from your integration, we add here, this is x. So it's same as to the power of 1. So we're going to add 1, then we divide by 1 plus 1, which is 2. So that's x squared over 2. So it's you add 1 to the exponent, then you divide by the new exponent that you're having. So this is going to be x squared over 2 plus the integral of 1. 1 is a constant. With respect to x, it is going to be x. 2 over x. Remember, the integral of, if we are given the integral of k over x with respect to x, it is going to give us k ln x. So this is the one that we are having in this case. So our k is 2. So this is going to give us 2 ln x minus 2. This is going to be minus 2 ln x plus 1. In place of x, this can be plus a. So it is going to be x plus a, or whatever that you're given in this case. So that's x plus 1 in this case. All right, with the limits, don't forget the limits, 1 up to 2. So what does the limits mean? We are substituting the upper limit. This is your upper limit. This is your lower limit. So we are going to substitute upper limit minus the lower limit, meaning to say, in place of x, wherever there is x, you substitute the upper limit, which is 2. So that's 2 to the exponent of 2 over 2, plus in place of x, you substitute 2. In place of x, you substitute 2. In place of x, you substitute 2. So that's minus ln 2 plus 1, which is 3. So this is what you have for the upper limit minus the lower limit when x is equal to 1. So that's 1 squared, which is 1 over 2, plus x, which is 1, plus 2 ln of 1, minus 2 ln of 1 plus 1, which is a 2. So this is what you're going to have. We have substituted each and every part, upper limit minus the lower limit. All right. So from this case that we have, what we are going to do is to simplify. So if you are to simplify these 2 squared over 2 plus 2, this is going to give us a 2 in this case. So we've got 2. What you're going to do, we can leave this part as it is, which means we can leave 2 ln 2 minus 2 ln 3. We do not know what's going to happen with the other part, so let's just leave it for now. Minus, we simplify this part here, that's 1 over 2, plus a 1, which is going to give us 3 over 2. So this whole part is going to give us 3 over 2. But know that ln 1 is a 0. So ln 1 gives us a 0, so which means this whole part is a 0. So we're going to remain with minus 2 ln of 2 like this. All right, so let me just remove this bracket. Let's expand with the negative direct. So it's minus times 3 over 2, which is minus 3 over 2, minus times minus 2, that's a plus 2 ln 2 in this case. All right, so this is going to give us a plus 2. We are given a negative in this case. So if you are to expand with this negative that is outside, it is going to give us a positive. So let's see what you're going to have in this case. If you are to collect like terms, that's 2 minus 3 over 2. So that is going to give us 1 over 2. So this will give us 1 over 2. If we simplify, this is 2 ln 2 plus 2 ln 2, we can add because this is ln 2, so we can add 2 plus 2, which is 4 in this case. So we're going to have 4 ln 2. So it is going to be 4 ln 2 minus 2 ln 3. So you can leave your answer like this, or you can combine this. Remember from your laws of logarithms that if you are given a ln b, in this case, you can raise a to be the exponent, which is ln b to the exponent of a. So you can raise the 4 to be the exponent of 2, the 2 to be the exponent of 3. So that means this can give us, in this case, let's see what you're going to have. So that is going to be a half plus ln 2 to the exponent of 4, which is 16, minus ln 3 to the exponent of 2. That is 3 to the power of 2, which is a 9. Take note, this is 2 to the power of 4, 16, 3 to the power of 2, which is a 9. So we are subtracting. So we know that from our laws, if we are subtracting ln of A minus ln of B, we are going to divide the numbers under the same log or the same ln. So this is going to give us, if we are to simplify these two together, that is going to be half plus ln 16 minus ln 9. This is going to be ln 16 over 9 as a single term. So that is what you're going to have in exact form, or even you can even leave it at that state. But this is the exact form that you can have. And as you can see, we can't reduce 16 over 9. So you're just going to leave it like that. Okay, so that was the question on integrating f of x. So as you can see, it's a continuation from the f of x that you got previously. When you resolved into partial fractions, you are going to continue from there. You integrate. So meaning to say, you are supposed to make sure that your first part is done properly. As you can see, it's affecting the second part where you are now integrating. So integration is another topic on its own, which is the one that you're going to check. Yes, we never had this one for our A level, but we are going to check it as a separate topic. But you can even check for other classes for engineering and so forth. You can see a lot of things that you have done under factorization, you can see a lot of things. All right, so I want us to check the other part of the question. This first part, it's fine. It was actually 8 marks for that, so you can play around these typical questions from your past exam papers that can actually help a lot. So this is the first part. The second part, we are given question 2, which is express this into this format. All right, so let's check. I'm going to have this as a separate question. So it's just 3 marks to express this whole fraction into this, and we are given the format. So sometimes when you're answering, when you are given questions from these past exam papers, they try by all means to give us a certain hint on that question. All right, so that's our question 2. We are given 5x to the exponent of 3 minus 3x squared plus 7x minus 3. All right, everything over, that's x squared plus 1 to the exponent of 2, which is equal to ax plus b. So take note here, over x squared plus 1 plus we are given cx plus d, everything over x squared plus 1 squared. What is happening here? We talked of linear factors before, and we talked of repeated linear factors. What about this one? This one is a repeated quadratic. It's a this part, we cannot factorize this x squared. Take note, guys. X squared plus 1. We can't factorize this. So it means we are having a quadratic where you can express as ax plus b. But the squared now, we are repeating the same quadratic that we had before. So that is why we are having cx plus d for another quadratic, which is repeating. And we raise to the power. So remember, we start with 1, 2, depending if this was to the power of 3, which means we are going to have ex plus f over x squared plus 1 to the power of 3. And so depending with the power that you are given in that case. All right, but in this case, this is to the power of 2. That is why we are ending up to the power of 2. So this is what we're given in this case. And already the format is given. So if not given, be very careful how you expand a repeated quadratic. All right, so in this case, an advantage already, they have done a certain part for us. What are we going to do? We are going to equate our numerators. That is 5x cubed minus 3x squared plus 7x minus 3 in this case is equivalent to, we have got ax plus b in this case. So this is ax plus b into, if we are to divide x squared here, this part here of x squared plus 1 squared divided by x squared plus 1, this one and this one will cancel. We remain with one bracket. There are 2 of them. Take note, there are 2 brackets. So we're going to remain with the 1 bracket of x squared plus 1. All right, we move on to the other part here. We have got cx plus d. So if we are to divide this whole part of x squared plus 1 squared and x squared plus 1, these 2, they're actually the same. So they will actually cancel. That means we remain with the 1. So this is just going to be cx plus d. There is no need for the brackets. But checking into what we have, we can see that it's actually difficult to, we can't even find any value of x by equating any of these brackets. So which means it's a waste of time. So what can we do? We are going direct into expanding of brackets. So we are going to expand our brackets in this case. So expand brackets and equate the coefficients, meaning the left-hand side is going to remain as it is, 5x to the exponent of 3 minus 3x squared plus 7x minus 3 is equal to, let's expand, ax is going to affect x squared, it is also going to affect x. After, b is going to affect x squared and is also going to affect 1. So this is going to be ax times x squared, which is ax to the exponent of 3, ax times 1, which is going to be ax. We are done with ax. We move on to b times x squared. that's bx squared. B times 1, which is a plus b in this case. All right, we are done with this bracket. This is going to remain both. There is a 1 here, so 1 times cx, that is cx, 1 times d, which is a d. So we have expanded. Now we can equate the coefficients. By doing so, we can calculate any constant value, a, b, c, or a d. All right, so that's it. Let's check here what we can do. Let's work with the coefficient of x to the exponent of 3. So we're going to work with the coefficients of x to the exponent of 3. So on the left-hand side, we've got 5, which is equal to the right-hand side, we've got a. We also have here x to the exponent. Okay, it's just this one only. We do not have another one. So it's just this one. So which means a is equal to 5 because we do not have any other term with x to the exponent of 3. So which means that is what you're going to have. A is equal to 5. All right, we move on to the other part. This time we are going to equate the coefficients of x squared. All right, working with x squared, the coefficient of x squared here, that's -3. So -3 is equal to the coefficient of x squared. In this case, we just have b. That's what we have, just a b. So that means our b is equal to -3. We have the value of b. The same thing, we move on to the constants, so to x, so you can have the coefficients of x in this case. So on this part, the coefficient of x on the left-hand side is 7, which is equal to the coefficient of x on the right-hand side. We have got a. The other coefficient of x on this side, the right-hand side, we've got c. So this is a plus c. But remember, before we calculated the value of a and we obtained a 5. So we can substitute a, which is equal to 5, to obtain the value of c. So 7 minus 5 is equal to c. C is equal to what? Is equal to 2. So we can now determine the value of d by equating the constants alone. We can work with the constants part in this case. All right, so working with the constants. So the constants in this case, that means on the left-hand side, the constant is -3 is equal to, on the right-hand side, the constants, we've got b and d. So this is going to be b plus d like this. So that means we can substitute whatever that we have. B, we have it, it's -3. So that is going to be a -3 here. So substitute, if we are to transpose to the left-hand side, it's going to be -3. If we transpose -3 on this side, it's going to be a +3 is equal to d. So that means d is equal to 0. -3 plus 3, that's a 0. So we have the values of a, b, c, and d. So we can substitute back into the equation, into our partial fraction, in this case, the one that you're given here. So remember that we expanded. So I'm just going to use this one that we can see properly. So it means our f of x from here, we are going to substitute direct here. This one, we can see it properly. So we can say this is equivalent to a. We are now substituting the value of a that we got, which is 5. So it is going to be 5x. B, the b that we got, remember, b is -3. So it is going to be -3, everything over x squared plus 1. We move on, cx plus d. So it's going to be plus our c. We remember our c was 2. So this is going to be 2x plus d. Remember, d is equal to 0. So 2x plus 0, that's 2x, everything over x squared plus 1 squared. All right, so this is how we're supposed to express this whole function that you're given, our f of x, into this format that you're given. All right, so that was our question on question 2. So that is what you're given. In this case, express this into partial fractions, and we are given where a, b, c, and d are constants. So there are so many typical questions that you can work on or that you can do. So I want you guys to try and attempt the last question that we are given in this case, which is the question 4 from one of the question papers, to express 3x plus 8 over 2x plus 1 into x squared plus 3 into partial fractions. So that's 5 marks for that. So if you have to check Just a hint, as you are trying your question, please take note here. This is a linear factor, and this is a quadratic. You can't factorize x squared plus 3. So that means this is going to give you a over the linear factor of 2x plus 1 plus, for the quadratic, this is going to be bx. It must have x plus another constant. Why b? Because we have used a, we are now on b. So it is going to be bx plus c over the whole of the quadratic, which is x squared plus 3. Therefore, you can work it from there. So that's a hint. So I want you to try this question. Let me know your answers on the comment section so that we can proceed with other questions. And also for any other topic that we have, let us know on the comment section which topics to work on or which question papers to revise on. If you have a question paper and a question on that question paper, then you can just update on the comment section, write the question paper and the question number for any questions that you can send on WhatsApp on +27618644043. All right, so you can send your questions there so that we can revise your questions back on this channel or at Maison African Motives. So that's it for now, till we meet again.